Dear students, yesterday we have discussed the Fourier transformation and we have done some problems. You can go through this problem section 11.1. These are graphs of Fourier series periodic functions. You can draw this graph, and you can find out the Fourier series for these problems. Okay. And now we move to the section and arbitrary period, even and odd functions, half range expansions. Okay. So instead of restricting to the period to 2 pi, we consider period p equal to 2l. Okay. 2l. So now the now onwards we will consider the period p equal to 2 pi 2l. Okay. So let us introduce a new variable v, small v, as a function of 2 pi, Okay, let x equal to p by 2 pi into v, so that v equal to 2 pi by p into x. That is, since p is equal to l, p by 2 will be l, so we can replace like this, pi by l into x. So v is equal to pi by l into x. So that is the new variable. Okay. Then v equal to plus or minus pi whenever x equal to plus or minus l. If we put x equal to l, then v equal to pi. When if we put minus l, you will get v is equal to minus pi. So again the variable v will be having the period 2 pi. Okay. So we have transformed the variable x into v, so that but remember that x is having period 2l, at the same time v is having period 2 pi. Okay. So from the function with period 2l, we have transformed that variable, and the function will be function with new variable will be in between minus pi and pi. So that is the beauty, because we know the methodology for finding Fourier series with period 2 pi. So the arbitrary period is transformed into 2 pi period by this transformation, as we seen in the equation number 1. Okay. So f of x equal to, we can write f of l by pi into b. So usually it will be some a naught plus summation I, because it is a Fourier series, a naught from summation I from 1 to n, 1 to infinity, bn into sin nv. Okay. So we can represent like that. Okay. So what is how can we obtain the coefficients? Because this function is having, if we consider the function in terms of v, it will be having 2 pi. So a naught will be equal to what is that? 1 by 2 pi into integral minus pi to pi f of l by pi v dv, and an, as we seen in the previous section, an is equal to 1 by pi into integral minus pi to pi f of, instead of x we use l by pi l by pi into v cos nv dv. Okay, bn is equal to 1 by pi into integral minus pi to pi f of l by pi b sin nv dv. Okay. So we have taken v is equal to pi by l into x, so that dv equal to pi by l into dx. We can replace that. Okay. So f of x equal to a naught plus summation n from 1 to infinity n into cos n pi by lx plus bn. So instead of v, we substituted n pi by lv. Instead of nv, we substituted n pi by l into x plus bn into sin n pi by l. So what is that? So we can so instead of pi we can write minus pi, we can write and this is so from this we can obtain the formula by transformation, by using the transformation. Okay, so we can transform that into this this is v, but we can transform x. Instead of v we can substitute pi by l into x. So pi by l into x, that is v. Okay, so that is considered here. Pi by l into x. The range of integration will be, if we transform like this, the range of integration will be minus l to l. So a naught will be equal to 1 by 2 l into integral minus l to l f of x dx, and an will be equal to 1 by l into integral minus minus l to l f of x into cos n pi x by l dx, and bn will be equal to 1 by l into integral minus l to l f of x sin nx into n pi x by l dx. So if we consider the variable v, then the range will be minus pi to pi. Correspondingly, if we consider the variable v, then the range will be minus l to l. Okay, and what is that? As in the previous section, this constants outside this integration will be 1 by 2l, and because we have discussed in detail in the previous class. Okay, so the method of finding these steps. So similar step holds for this section also. So we obtain a naught, an, and bn. So these are the coefficients. So coefficients of the equation number 5. Okay, so let us consider some examples. This is an example, typical example. F of x equals 0 if minus 2 less than x less than minus 1, k if minus 1 less than x less than 1, 0 if 1 less than x less than 2. Okay, the range, what is that? The length of the interval of the length of the function interval under consideration is minus 2 to 2, that is 4. So 2l will be 4. So l is equal to, normally l equal to 2. So you can see that after substituting in equation 6, you can see that a naught equal to k by 2. You have to verify. Okay, a1 will be equal to 1 by 2l, that means 1 by 2 into 2, sorry, 1 by l. So 1 by 2 into integral minus l to l, that means minus 2 to 2 f of x into cos. So you can k can be substituted in between minus 1 and 1. All other regions k will be 0, so we can consider only minus 1 to 1. So k into cos n pi x by 2 dx, 2k by n pi sin n pi k. After integration it will be sin n p by k, and you can substitute 1 and minus 2. Okay, so n, since it is 0, since it is sin 0 0, sin pi 0, sin 2 pi 0, etc. You know, so if n is even, an will be n is even, that means 2, 4, 6, etc. Then an will be 0. And sin, if n is odd, then an equal to 2k by n pi into, this can be 1 or minus 1. Okay, yeah, it is 1 for 1, 5, 9, etc. It is minus 1, sin will be minus 1 for n equal to 3, 7, 11, etc. Okay, similarly we can find out bn. Bn will be 0 because after integration it will become cos. Okay, what will be the n values here? This integration will be here. It will be if we consider bn, we have to substitute sin here, and if we integrate this one, it will be cos, and cos minus 1 equal to cos 1. So that will be 0, and their function bn will be 0. So we will have only what is that, an terms. So you can use that substitute that an terms here, and bn equal to 0. Then you will get the series like this. So you have to verify this problem. You have to work out in your notebook. Okay. A naught is here, A naught is here, then this is an, this is the minus term for these are all n terms, but positive terms for n equal to 1, 5, 9, etc. Negative term for n equal to 3, 7, 11, etc. Okay, so you have to check that. So another problem, it is another problem. You can do this problem also. Okay, only some steps are given. You can elaborate that example steps. Okay, find the Fourier series of the function f of x equal to minus k if minus 2 less than x less than 0 and k if 0 less than x less than 2. So the entire length is minus 2 to 2, that is 4. So L will be equal to 2. Okay, so and you can use, what is that, b is equal to pi x by L, that means pi x by 2. Okay, and as we seen in this previous problem, you can find out a naught, an and bn, so that the series, the final series is given, g of is equal to 4 by k into sine. So cos term becomes 0. So here also we will have a naught will be 0. I think I expect a naught equal to 0. You can verify that, and then an will be 4k by pi into this is a1, then a3, a5, etc. I think so. So you can verify that, so that the Fourier series will be like this. Instead of nu, we can substitute pi by 2x. Okay. So you have to verify this problem also. Now we consider even and odd functions. So what is an even function? What is a basic requirement for a function to be even? That is f of minus x equal to f of x. Cos x is an even function because cos x equal to cos minus x. X square is an even function. That means x square is equal to minus of x whole square. So in that case, you can see that the Fourier series becomes a naught plus summation n from 1 to infinity n into cos n pi by n x if f is even. Okay, and the constants are 1 by L into, because since f of x is even, we can modify the integral minus L to L as 2 times integral 0 to L. Okay, for an even function, you know the result that integral minus a to a f of x dx equal to 2 times integral 0 to a. So similar argument can be applied here. So instead of 1 by 2L, so 1 by 2L into 2 times integral 0 to L f of x dx. So 2 will be get cancelled, and the remaining term is 1 by L into integral 0 to L f of x dx. In the case of an, you know, f of x is even, cos is even, so the entire function inside the integral will be even. So since it is even, you can write like this: 2 into 1 by L into integral 0 to L f of x cos n pi x L dx. Okay, and for the Bn function, f of x is even and sine will be odd function, so the entire function will be odd function. So integral minus L to L will be 0. Okay, so Bn will be 0. So that is why the Bn term is not appearing here in equation 5 star. Okay. So now we consider f of x is an odd function. What is the definition of odd function? f of minus x will be equal to minus f of x. Sin x is an odd function. Sin minus x equal to minus sin x. Okay, x is an odd function. Minus x equal to minus of x. Okay, so this is the odd function. So in that case, we will have the Fourier sine series. That is, since the integration is from minus L to L, the a0 term will be 0 because this is odd function. Okay, and moreover, cos is an even function and f of x is an odd function. Then the product will be odd function, so that an will be 0. Okay. Now bn will be what is that? Like this. Bn will be integral 1 by 2 pi into integral minus L to L. This is an odd function, this is an odd function, so we have to integrate. We cannot have it is 0, it will have a result. So f of x into sin n pi by x by L dx. Okay. So it will be Fourier sine series. For an odd function, f of x will be f of x will be Fourier sine series. Okay, b1 will be like this. Okay. So okay, that's enough. You can go to the summary. Yeah, for an even function, for an even function with the period 2 pi, then f of x equal to a0 plus summation n from 1 to n a n cos n x with the coefficients a0 equal to 1 by pi into 0 to pi 2 f of x dx a n 2 by pi 0 to pi f of x sin cos n x dx. For an odd function with the period 2 pi, f is an odd function, L equal to pi. Then this is the even function with the period 2 pi is a special case of even function with the period 2L, and odd function with the period 2 pi is a special case of odd function with the period 2L. So we can consider this as a special case of previous discussion. Okay. So if L is an odd function with the L equal to pi, then f of x equal to summation n from 1 to infinity bn into sin nx with the coefficients bn equal to 2 by pi into integral 0 to pi. So instead of L we use pi, it is 0 to pi f of x sin nx dx n equal to 1 to 3 etc. Okay. So let's consider some examples. അതായത് ഞാൻ പറയാനുള്ളതൊക്കെ പറഞ്ഞു. ഞാൻ പല പ്രാവശ്യം പറഞ്ഞു, അത് പ്രകാരമാണ് അവിടെ എത്തിയിരിക്കുന്നത്. ഇനി നിങ്ങൾ പറയില്ല, ഓഫീസിൽ പറയാം. അതും നിങ്ങൾ വിളിച്ച് പറയാം, നിങ്ങൾ പ്രിൻസിപ്പാൾ പറയുന്നത് വിളിച്ച് പറയാം. അല്ലാതെ ഇനിയിപ്പോൾ ഞാൻ പല പ്രാവശ്യം പറഞ്ഞല്ലേ, ഞാൻ പറഞ്ഞ പ്രകാരം കൊണ്ടുവന്ന പ്രിൻസിപ്പാൾ പറഞ്ഞ പ്രകാരം ആണ് ചെയ്തത്. അപ്പോൾ ഞാൻ പറഞ്ഞ പ്രിൻസിപ്പാൾ പറഞ്ഞ കാര്യം ചെയ്യാൻ ആൾ ചെയ്തു. ഇനിയിപ്പോൾ നിങ്ങളാണ് നിങ്ങളുടെ ഭാഗം ചെയ്യുക. ഞാനൊരു 10 പ്രാവശ്യം പറഞ്ഞിട്ടുണ്ട്. ഓക്കെ. ഞാൻ വിളിക്കാം. ഒരു മിനിറ്റ്, ഞാൻ വിളിക്കാം. ഞാൻ ക്ലാസ്സിലാണ്, ഞാൻ വിളിക്കാം. So I think this is an example. let us consider the example of okay, we have only two examples in this section. Consider this function. Okay, find the Fourier series of the function f of x equal to x plus pi if minus pi less than x less than pi, and f of x plus 2 pi equal to f of x. So this is the function we are considering. Okay, so let us consider function in this form. F of x equal to f1 of x plus f2 of x. What is f1 of x? f1 of x equal to x and f2 of x equal to x. So we can split up this function into two terms. F of x equal to f1 of x plus f2 of x. Okay, so in that case we can try to find out the Fourier coefficients. So instead of f, we can substitute f. Okay, so this is the format of the function. F of x, this is the shape of this function. Function will be look like this. Okay, since it is periodic, 45-degree line in a period. Then f1 is odd because f1 is x. So for an odd function, an will be 0. Okay, and bn will be, what is bn for the function f1? 2 by pi into integral 0 to pi f1 of x sin n x dx, that equal to 2 by pi into integral 0 to pi x sin n x dx. We can apply the rule of integration for the product of functions. So that will be first function into integral of second minus integral of integral of the derivative of first function into integral of second, and in that range. Okay, so you can use that formula and you will get, it will be like that, minus 2 by n into cos n pi. Okay, so that b1 equal to b2 equal to, if we put n equal to 1, it will be cos pi is 1, sorry, cos pi will be minus 1. Okay, cos pi will be minus 1, so that b1 equal to minus 2 into minus 1, that is 2. Okay, b2 equal to, put n equal to 2 here, so that you will get b2 equal to 2 by minus 2 by 2 into cos 2 pi. Cos 2 pi is 1. Okay, cos 0 is 1, cos 2 pi is 1, etc. So b2 is equal to minus 2 by 2. Similarly, we can find out all other values. Okay, so n is 0, b is, and we have f2 is equal to pi, so we need not to integrate and find out all the coefficients for this pi function. We need to just add that pi here. Okay, so f of x will be f1 of x into f1 of x plus f2 of x. f2 of x is already pi, so we can substitute here. Then f1 of x is nothing but this one. Okay, that will be bn into cos minus 2 to n cos n x into bn into that term, sin term. Okay, so that will be so the result will be like this. So we have used the what is that technique for the odd function and even function here. Okay, so I think that example is over. Now I think these are examples, you can refer these examples also. Moreover, you will have some examples in the exercise section. You can go through that problems also. Okay, we need not to consider this section. considering this section because it's not in this in your syllabus. Now we will consider Fourier transformations. Okay. Yeah, Fourier integral. I think you have studied the integration, Riemann integration, and Riemann-Stieltjes integration, Lebesgue integration, Lebesgue-Stieltjes integration, etc. While we considering periodic functions, okay, we can consider this Fourier integrals, okay, so that you will get the results in a different way, okay. So consider this function fL of x equal to 0 if minus L less than x less than minus 1, and 1 if minus 1 less than x less than 1, and 0 if 1 less than x less than n. What happens? What is the range? What is the range? What is the value of 2L? 2L is what is that? We can consider 2L is equal to minus 2 and 4 or 8 or 16 as well. Okay, we can take any one of the value 4, 8, 6, etc. for 12. So what happens if L going to infinity? What happens if L going to infinity? Yeah, we can write like this because minus infinity to minus 1 it will be 0, minus 1 to 1 it will be 1, and 1 to infinity it will be 0. So we can just write like this: f of x equal to limit L tends to infinity f L of x 1 if minus 1 less than x less than 1, and 0 otherwise. You need not to write the all other regions. Okay, there are two regions, that is before minus 1 and after 1. So instead of that we can write just 0 otherwise. Okay, so what is the Fourier series of this f of x, limit of this Fourier function? Okay, what is the Fourier series? So for that we have to find out a naught, a n, bn. Okay, so you can consider a naught, a n and bn. Since this is even, so bn will be 0. So a naught and a n will be computed like this. So you will get a naught 1 by L and n by L. Now we consider fL of x equal to the general form of the Fourier series. There is a naught plus summation n from 1 to infinity a n into cos omega nx. Sorry, cos wnx plus bn into sin wnx. We used n pi wn for n pi by l. Okay. So what happens when L tends to infinity, as we seen in this problem? We have seen a problem. What happens in this problem? It converges to 1 and 0. Okay, 0 in two regions. Okay. So what happens when L tends to infinity in this L of x? What happens? Yeah, we are checking the behavior of that limit. Okay. Now let us integrate that function from minus L to L. fL of x equal to, this is actually from the previous section we can see that a naught is nothing but A naught will be 1 by 2L into integral minus L to L, L FL of U dV. And what will be AN? AN will be 1 by L into integral minus L to L dV. BN 1 by L into integral minus L to L FL of V sin WN V dV. Okay. So we can integrate that function and you will get the constants A naught, AN and Bn, and we can substitute that AN, A naught, AN and Bn in this format and you will get this form. Okay. Now we set delta W is equal to Wn plus 1 minus Wn. Set the change. Okay. N plus 1 pi by L minus N pi by L, that equal to pi. What is 1 by L? 1 by L is delta W by pi. From this equation we can see that 1 by L is delta W by pi. So we can apply that apply this result, that is delta W equal to pi by L and 1 by L equal to delta W by pi here in the above formula. So you will get FL of x equal to 1 by 2L into integral minus pi to FL of V dV into, instead of 1 by 2L we can write it as what is that? Sorry, instead of 1 by L we can write it as delta W by pi. So delta W is appeared here. So 1 by pi is taken outside. So 1 by pi into summation n from 1 to infinity cos Wnx, that is already there. Delta W comes from the substitution of 1 by L. So then integral minus L to L FL of V cos Wn V dV plus sin Wnx delta W by pi. So 1 by pi is taken outside and delta W kept here. Integral minus L to L FL V sin Wn V dV. Okay. So what happens when we apply limit L tends to infinity to both sides? What happens? You know, when we apply this limit, then you can see that left side is nothing but f of x is equal to limit L tends to infinity FL of x. Okay. And we are considering that you know, this is we are considering, that is, this is absolutely integrable. That means f is integrable, that we are assuming. Okay. So we are assuming the integrability of function f. Okay. So using that integrability assumption, you know, if L tends to infinity, 1 by L tends to 0. Okay. Delta W equal to pi by L tends to 0. Okay. So what happens? Yeah, then f of x is equal to 1 by pi. The first term will be going to 0. And the second term, what about the second term? 1 by pi into integral 0 to pi cos Wx. So this is from the, what is that, integrability or convergence concept coming from Riemann integration, Riemann series integration, etc. You know that in Riemann integration, you can see that the summation, this type of summation will be some lower sum and upper sum, and in between you can see that the actual function, actual integration. Okay. So in the Riemann theory of integration and Riemann series theory of integration and integration theory, you can see that this summation will be converging to integral value. Okay. So we use that idea here. So that summation, instead of summation, you can write like this, into 0 to infinity, because in the Riemann integration and the series integration and Lebesgue integration, we are approximating the integration value with the lower sum and upper sum, or the, what is that, we will consider the integration value as limit of lower sum and limit of upper sum. Okay. So similar theory can be used here, and so using that theory, it will become 0 to infinity cos Wx integral minus pi infinity to infinity f of p cos Wv dv plus sin wx integral minus pi to pi infinity f of p sin wv dv dw. So that theory is applied here, and we can introduce these terms so that we can replace all these or the integration inside this uh, boxes, okay, brackets. So let us denote aw is equal to 1 by pi into integral minus infinity to infinity f of v cos wv dv, and b of w is equal to 1 by pi into integral minus pi to minus infinity to infinity f of v sin wv dv. Okay, so that we can simply write like this: f of x equal to integral 0 to infinity aw cos wx plus bw sin wx dw. Okay, so this representation is called Fourier integral. So if you have to understand the Fourier integration, you have to start from the what is that representation, okay, fl of x, and then fl of x is modified like this, and we have used some substitutions, and we have used some absolute results in the integration theory, existing integration theory, and we have substituted that integral inside the brackets as aw and bw, and you get f of x like this. So this is called Fourier integral. So f of x can be represented as a integration. So that is the beauty of this Fourier integral. Okay, in the Fourier series, f of x is represented as a series expression of some trigonometric functions. So in Fourier integration, actually the function itself is represented as an integral value. Okay, so there are plenty of applications for this Fourier integral, because a function is represented as an integral. So there is a different look. Okay, we can represent a function as a series, or we can represent a function as a what is that, arrangement of some other functions, but it is very this approach is very different. A function is represented as an integration. Okay, so that is called Fourier integral. So and the expressions are given here. So let us look at an example. F of x equal to 1 if mod x less than 1 and 0 if mod x greater than 1. This is the shape of the function. So a of w is equal to 1 by pi. You can just substitute the function, given function in that region. That's only. Just a numerical calculation, mathematical calculation is involved. So I think you might have the sufficient mathematical knowledge to study all these steps. We cannot repeat all these steps again and again. You should have some basic knowledge at the BSc level. I think if you are from BSc statistics background, you should have the knowledge at the BSc mathematics level. So you have to study all the steps. Okay. So AW is calculated like this, and BW will be equal to 0. Okay. So that f of x equal to 2 by pi into integral 0 to infinity cos wx. The value is 2 sin w by pi w. So we have substituted that here, and 2 is taken outside, pi is taken outside. So the remaining term will be inside that integral value. Okay, so that will be this one. And moreover, you can see the value of this integration will be from the what is that we can obtain what is that since this is trigonometric function, we can consider the left and right hand limits of f of x at x equal to 1. So what is the left limit and right limit at x equal to 1? Left limit and right limit x equal to 1. Left limit will be 1. Okay, left limit will be 1 f of x. The left limit value will be 1. Let us look at that. Right limit will be 0. Okay, this is left limit. So from the left side, when we approach x tends to 1, from the left side it will f of x will be 1, and the right, from the right, if we approach x from right, it will be 0. So that 1 by 2 is taken. Okay, and you can use that information here. Okay, 2 by pi, that will be 2 by pi will be come to left side, so that this function will be pi by 2. Okay, okay. Similarly at x equal to 1, the value will be pi by 4, because at x equal to 1, okay, we can I think we can substitute that value. So at x equal to 1, we can substitute this 1 by 2. So 1 by 2, 2 comes here. Yeah, at x equal to 1, in the region 0 less than x less than 1, we consider on the left limit value, that is 1. So f of x is 1. So that in that case we will have pi by 2. At x equal to 1, we have to consider this middle value, that is pi 1 by 2. F of x equal to 1 by 2. So 2 comes here and pi go upward, so that you will get pi by 4. Okay, so this integration takes these values. Okay. Okay, so let me stop here. You can consider more examples from the exercise also, and we will discuss this Fourier cosine integral and Fourier sine integral in the next class. Okay, I think we have a limited number of classes, and